Okay, so we've been talking about these angles. Let's just kind of throw some things together here just to make sure we have them. When we go to classify angles, of course, an angle that makes a square corner or 90 degrees is called a right angle. The word right actually comes from the connotation of correct. If you're building, it comes from construction. If you're building something, if it's a square corner, then it's built right. Makes sense? That's where the wording comes from. No, there's a lot of wrong angles in houses too, I know. So if you got something that is smaller than 90 degrees, it is called acute. How about something that is bigger than 90 degrees? Obtuse. Very good. By the way, whenever there is an angle formed, there's always an obtuse angle. Like obviously here, there's always two angles formed. There's always an obtuse angle of some form. This red angle over here is obtuse. So what we're talking about is the smallest angle formed by the two rays. Like here, this one actually forms two obtuse angles. So we're always what's called the minor angle, or the minor arc of the angle. We're referring to the smaller of the two. We've also talked about angles that share a side. Do you remember what those are called? Adjacent. Very good. And the nice thing about adjacent angles is they are additive or subtractive. If we know that this one here is 27 degrees, then this one here is 61 degrees. This angle has to be 88 degrees. Very good. If I tell you that this angle here is 39 degrees, what's this angle here have to be? 39 degrees. Anybody remember what that pair of angles is called? Vertical angles. Very good. They're vertical angles are formed on opposite sides of two intersecting lines, therefore they have to be the same. Let's throw in there, what does this one have to be? 180 minus 39, giving me 141 degrees. What is this combination of angles called? Are they complementary or supplementary? They're supplementary. Remember, complementary is 90 degrees. You get complements when you're right. Those two lines, if I drew them correctly, would be referred to as parallel. If I give you that angle, 53 degrees, what is this angle? Okay, what is this angle? Okay, so 127, right? 180 minus 53. What's this angle? 127. What's this angle? How about this one? This one? 53. This one? 53. Whenever we have parallel lines cut by another line, like this, there are only two unique angles formed. So any pair of angles are either equal or they're supplementary. What is that red line called that it drew through there? Transversal. Very good. We're talking about triangles, we'll come back to more transversals. So let's say I have a known angle. Let me even call this 52 degrees. I'm going to construct another angle. And the sides of that angle are going to be parallel to the sides of this angle. What does that new angle have to be? Parallel to the sides of this existing angle here. Well, like here, there's a line that's parallel to that side, right? I can draw lines parallel to the other side. There's a line parallel to the other side. What's that angle that I created have to be? Is that the only angle that can be created? So is that parallel to one side of the angle? For the most part. Is that parallel to the other side of the angle? Yep. Is that 52 degrees? Nope. What's it got to be? If I were to take this and slide it up there, yeah, that would form a straight line, wouldn't it? So that has to be supplementary. 180 minus 52, or 128 degrees. So if I have an existing angle and I form another angle by making lines parallel to its sides, I either get an angle that's equal to it or one that is supplementary.
Anything beyond that line would be 52. Right?
Yeah, probably, yeah. It just depends on whether you're going towards the angle or away from the angle with it. Yeah. So this one's 47 degrees. This time I'm going to construct lines that are perpendicular. What's perpendicular mean? Intersects at a right angle in every possible measurable direction, right? If I draw in lines that are perpendicular to the sides of this triangle, or this angle, what does the angle have to be? So if I draw this in, it's 90 degrees. I draw this in, it's 90 degrees. What do they have to be? Are they 47? Nope. It can't be, this one's obviously obtuse, so it can't be complementary because complementary would add up to 90. This is already more than 90. Supplementary would be the way it'd be. A four-sided figure, there's something called the angle sum that we're going to talk more about in a little bit. Has to be 360 degrees if there's four sides. So that's 90 and 90 adds up to 180, right? So there's 180 left for these two angles, so those two angles have to be supplementary. They have to add up to 180. So this will be 133 degrees here. But is that the only angle that could be formed? No. By being perpendicular doesn't mean it has to intersect. It can be perpendicular and be drawn up here as well. I could have that angle there, which would be 47. So once again, if we create another angle from an existing angle by making sides perpendicular to its sides, the new angle formed is either equal or supplementary. So now that we've defined all those different angles, let's talk about triangles. Triangles, of course, have three sides. We can classify triangles in two different ways, by their angles or by their sides. If we classify them by their angles, we classify them by the largest angle. So the most special one here would be like this. Its largest angle is a right angle. So that's called a right triangle. We have a triangle like this. Are any of those angles bigger than 90 degrees? No. So its largest angle is acute. That's an acute triangle. We have a triangle like this, where its largest angle is obtuse. That is an obtuse triangle. fairly simple. If we're classifying by its sides, we're going to have something like this. Those little marks indicate if they have the same number of little hash marks, they're the same length. Well, none of those are the same length. This is what we call scalene triangle. That one has two sides that are the same. It would be called isosceles. And of course, all three being the same is equilateral. Now, if you want to be very descriptive of a triangle, you can describe it both ways. Now, some triangles it doesn't pay. Just if you describe it a certain way, it implies the rest. But we can have that would be what if I described it by the angle, right? And what if I described it by the sides? Isosceles. That would be called an isosceles right triangle. What's the biggest angle in that? Acute. And it is also isosceles, so that'd be an isosceles acute triangle. Anybody want to guess what this one would be called? Isosceles obtuse, or obtuse isosceles, either way. Now, would we ever want to say like an equilateral acute triangle? Equilateral is always going to be acute, isn't it? How about equilateral right? That doesn't make any sense, does it? No. You have a scalene right triangle or a right scalene triangle. But if we don't say isosceles is really the only one that we usually point out, unless it is equilateral, then it's just equilateral. Isosceles is the one that tends to get combined with the others, just because if we don't say anything, we assume it's scalene. If we just say a right triangle, we assume it's scalene, that all three sides are different. Unless proven otherwise. But the big thing about a triangle is, again, that angle sum. We talked about the four-sided figure having an angle sum of 360. Of course, a triangle has an angle sum of 180. Now I'm going to go through something with you here to show you how we get that for a triangle and for any figure. Of course, n equals 3, because a triangle has 3 sides, 3 angles, 3 whatever you want to call it, right? So if I start walking in the direction of one side here, like this, when I get to the corner, I'm going to turn. Now I'm walking down this side. Get to the corner again, I'm going to turn. Walking down this side. Get to that corner again, I'm going to turn. I'm back in the same direction. So I'm going to call these angles here, I'm going to call these interior angles A, B, and C. This is going to be D, E, and F. Angles D plus E plus F have to add up to how much? Well, I made a complete turn, right? Make a complete turn, that's 360 degrees. Does that make sense? Okay. Now, A plus D has to be how much? 180. B plus E has to be how much? 180. F or C plus F has to be how much? 180. So that has to add up to 180, 180, 180 is 540, right? Now, A, B, and C are the interior angles. So I have to get rid of D, E, and F. Fortunately, I know how much D, E, and F add up to, which is 360. So if I subtract D, E, and F, I'm just subtracting 360 from the total. So you'll see basically what happened here is I had 180 degrees for each angle, and then I subtracted 360 from it. Does that make sense? For those outside angles that I didn't need. So if I know the number of sides in a figure, n, the angle sum is 180 times n minus 360. Now, algebraically speaking, they tend to rearrange this formula a little bit. They write it like this: 180 times n minus 2. Rather than multiplying by 180 and subtracting 360, 360 is just 2 times 180, right? So they tend to subtract 2 from n first, just to make it a little bit simpler to multiply. This way? Yeah. Well, especially if you're calculating in your head, this is easier to calculate. But this is the geometric way. That's where it comes from. They both give you the same answer. So if I have a figure with 6 sides, if n equals 6, a hexagon, what's the angle sum going to be? N minus 2 is 4, right? 180 times 4 is 720 degrees. So the internal angles add up to 720. What do you think? You ready for the sharp stick? That was a 6-sided figure. Looking at this triangle, I'll label angles A, B, and C. Which angle has to be biggest? B, why? It's, well, not necessarily obtuse, because it's drawn acute. It is across from or opposite the longest side. The opposite side is what determines the side of an angle, or the biggest determination of the size of an angle in a triangle. Obviously, A would be the smallest because it's opposite the smallest side. So when we label a triangle, we link the opposite side to its opposite angle. So if I label this angles A, B, and C, this would be side A because it's opposite angle A. This would be side little b because it's opposite angle B, and side C because it's opposite angle C. And what we just set up here is a hard and fast rule. The largest side is opposite the largest angle, or the other way around. And the smallest side is opposite the smallest angle, or the other way around. So if you know the sides, you at least know which angle has to be biggest. When we get into some of our heavier trig, like law of sines and law of cosines, that's something we have to keep in mind. If you have that largest side and you get an answer that doesn't give you that opposite angle being the largest angle, you did something wrong. Okay, for now, we're going to finish up our packet. In that packet, I gave you a couple of aids there, page 281, 1 through 12, and page 286, 1 through 24. That should, I believe that packet goes up to page 286, doesn't it? Okay. That's all, yeah. Those are just kind of vocabulary things. Is it 284? Where your packet ends? So I do have to give you the next one, okay? I don't know why I'm grabbing a handful. Really don't need that. We need to finish out this group.
Instead of waiting until the week tomorrow, go on until the weekend.
Still one short?
No. Wasn't here yesterday. He was Monday.
Oh. Sure. If you haven't figured it out yet, there are a lot of packets this semester.
Are we using the books at all? Or
We will
I
use
know,
the
we're
we will use the
using
big
this
book.
book.
We'll use the big book a little bit,
Not
but the little book you can pretty much put aside.
We'll lose some extra weight then.
Yeah, we get rid of the small.
The 1.2 pound book, huh? Hey, it's a start, right? In what, 11 more weeks, you get to get rid of all your books.
Oh, I'll probably hang on.
I was wondering, how many days are left for actual school days?
Actual school days, this is week 6, right?
Who knows?
I think so. So there's, wow, I actually lost track.
So there's 61 weekdays, and we have 10 of those off, so 51 days left.
Well, you've got the 5 days off.
Is that all?
Yes, no,
Until graduation, there's 60.
yeah, there's 10, so 52 days left of class. Actually, it might be one less because of Good Friday.
We get 10 days off, so.
Because you have the 5 days off for spring break. You have Wednesday off next week. Then you have Good Friday and Monday off after Easter.
Yeah.
So that's,
I mean, there's a teacher in service or two.
well, that teacher in service is next week. I think those are the only days off, though. Let's check.
Not according to the planner.
Let's take a peek.
One of them is a Friday.
Well, that's right. The last week ends on like a Wednesday, doesn't it?
Yeah.
Yeah, I did last semester too, didn't
That's something they're getting rid of too. Is they're trying to at least take those 3 days and put them within the semester somewhere, so you at least cut 1 week off the end. It's gonna be different next year because they're gonna try to have classes for 2 or 3 days over Thanksgiving. We tried that like 7 or 8 years ago.
Didn't work.
Nobody showed up. I mean, yeah, I mean maybe a third of my students in class. Mm-hmm. Yeah, a lot of high schools have given up on it.
What, they want to have school on Thanksgiving now?
Yeah, Monday, Tuesday at least. If not Monday, Tuesday, Wednesday. So let's see here.
Like they use those for their
You do have an in-service next week on Wednesday. You've got the 5 days off for spring break, so that's 6 days.
All day next Wednesday.
You got Friday, Monday off at Easter. And that's it. That's just those 8 days. But they're probably counting the Thursday, Friday after classes end.
That must be,
So next week, yeah, Wednesday's usually my long day, so I get to miss my long day next week. Cool. I can live with that.
next week, Wednesday?
None at all, not even my night class. No daytime or evening credit classes.
It's called a barroom class.
Well, technically, that's why we end on a Wednesday. Is that extra Wednesday class gets made up that last day. But realistically, I mean, literally, that is everybody's last class of the semester. How productive do you think I'm going to be? In that class. It's a 3-hour night class, which is hard enough to be productive anyway.
3-hour night class.
Yep. Have a good one.
So can I take it home or?
Yeah, go ahead and take it home with you. How are you doing getting caught up on everything?
Pretty good. I got this first done, but I just noticed I didn't do the last problem. I got a bunch of
Okay.
work done on it, so. Actually, I'll do it.
I've got to get the videos processed and put up for you, but we did discuss that in the video. That you got to use the working depth.
Mm-hmm.
You take the radii, which is, I gave you the diameter, so you got to divide each of those in half. You get the radii of the two gears.
Yeah.
Well, if those add up, that should be the distance from the center. But then if you look at the center to center distance I gave you, it's smaller than that total.
Mm-hmm.
So the difference between those is how far they mesh together. That's your working depth. So then you can use your chart. You can use the working depth. There's a formula to calculate the working depth from the pitch.
Mm-hmm.
So you have to use the formula backwards to find the pitch from the working depth. I know that's a lot of mumbo jumbo right there. You may have to ask again, but
Is that on video? No.
I've got to get the videos processed and put up there. But it will be, yeah.